see how to use the standard normal table to find the probability of a standard normal distribution. The standard normal table gives probabilities associated with specific z-scores. The table we use is cumulative from the left. The negative side is for all z-scores less than 0, and the positive side is for all z-scores greater than 0. But not all standard normal tables work the same way. The area percentage, or whether you call it percentage, proportion, probability, same thing. The area percentage calculated using a z-score will be a decimal value between 0 and 1 and will appear in a z-score table. The total area under any normal curve is 1. Since the normal curve is symmetric about the mean, the area on either sides of the mean is 0.5. So the total area is 1. So area from 0 up to here is 0.5, and area from this mean up to this side is 0.5. To find a specific area under a normal curve, find the z-score of the data value and use a z-score table to find the area. A z-score table is a table that shows the percentage of values to the left of a given z-score on a standard normal distribution. There are two z-score tables, negative and positive. So this is a z-score table, negative z-score table. The area is from left of the z value. So the area proportion given in the table represents the area to the left of the z-score. So whatever the value, for example, if we have got this value z, whatever, I don't know what's the value over here, but suppose it is something minus 2.5, so it is say 0.0049. So 0.0049 is actually this whole area, and the area to the right is simply 1 minus area on the left, and this is positive z-score. Cumulative areas from the left, again same thing, but here you can see the values of z are given in plus, and here how to read this table we will see. These tables are designed only for the standard normal distribution, which has a mean of 0 and a standard deviation of 1. The leftmost column is how many standard deviations above the mean to 1 decimal or below. Depends, because it is symmetric, it doesn't really matter whether it is above or below. So the mean, the leftmost column is how many standard deviations above the mean to 1 decimal place. So this one gives you 1 decimal place, and the part of the z-score denoting hundreds is found across the top row of the table. So this one gives you hundreds of the z-score. The intersection of the rows and columns gives the probability or area under the normal curve. As I've explained you, that these values give you the area under the curve, or the probability, because the probability is simply the area under the curve. Each value in the body of the table is a cumulative area. Cumulative area means that it starts from minus infinity up to this z value. So here you can see that, for example, we want to find the probability or area under the curve for z-score 1.62. So as it said that the leftmost column is how many standard deviations above the mean to 1 decimal place. So for 1 decimal place we'll see this 1.6, this is 1 decimal place. it is 1.6 over here, and these rows give us hundreds in the z-score. Hundreds, the part of the z-score denoting hundreds. So since we have got this 1.62, so 0.2 is here, 0.02, so altogether it is 1.62. This intersection of this 0.02 and 1.6 gives us the probability or area under the curve. So this is, but this, remember, this is cumulative area or cumulative probability from -infinity up to 1.62. Z-score tables come in different formats determined by where the computations were started. There are two most popular formats, cumulative from mean and cumulative from the left. The negative and positive z-score tables we saw earlier are cumulative from the left type tables. So these both tables over here, this positive z-score and this negative z-score, they are cumulative from the left type tables. Starting from -infinity, as I explained you before, that it starts from the negative infinity and going to the right up to the needed z-score. So whatever, for example, in this case the needed z-score is 0.36 here. In this case it was 1.62. So from infinity it goes up to that z-score value. This table works with the entire area under the normal curve and requires less adjustments than the cumulative from mean type. The cumulative probability for mean is 0.5 because it starts from infinity and adds all the probabilities up to mean, which is half of the total area. So the total area is 1. So area from this mean to the left or to the right is 0.5. Cumulative from mean z-score table. So starting at the mean and going to the right of the mean up to the needed score. So it starts from the mean score, rather instead of -infinity, it starts from the mean of the z-score. This table basically works with half of the area under the normal curve, and the user must take this into consideration and make adjustments when using this table. This type of table lists positive z-scores only. This type of table, when you are using cumulative from mean z-scores, you cannot use negative z-score tables. The probability at mean is 0. So in this case, when you are using this kind of table, in this case the probability probability at mean is 0. Here it was 0.5 because we are talking about the whole area. Here it is 0. Now let's have a look at an example. Adult deer population weights are normally distributed with mu is equal to 110 pounds and sigma is equal to 29.7 pounds. As a biologist, you determine that a weight less than 82 pounds is unhealthy, and you want to know what proportion of your population is unhealthy. So we want to find the probability, cumulative probability less than 82. So first of all, we have to convert this 82 into our z-score using this old formula which we have seen many times before. Z is equal to x minus mu divided by sigma. Value of x is 82, mu is 110, and sigma is 29.7, so we get minus 0.94. So now how do we find the value or the area under this curve? Minus 0.9 is here, and this part 4 is here. So minus 0.9 and 0.04, and we find the intersection of these two rows and columns and we get 0.1736. So from the Z-score table we get the probability 0.1736. It means that approximately 17.36% of the population of adult deer is underweight, or a deer chosen at random will have a 17.36% chance of weighing less than 82 pounds.